Hi and welcome. In this video tutorial, I am going to discuss about the interfacing of a common cathode 7-segment display with 8051 microcontroller. First, I have this simulation model of 8051 and 7-segment. The 7-segment display is common cathode type and it is connected to port 2 of the microcontroller. I have created a new project in MikroC compiler where I have defined the display port as port 2 with the help of this hash defined directive, and we have this empty void main function. Before moving further in this tutorial, I want to suggest you one more tutorial from my electronics devices playlist. Watch this 7-segment display working tutorial and you will get the basic idea how we can interface a common cathode display. In this tutorial, I will just write the simple program to display some values on the 7-segment display. Here I have this data table for common cathode 7-segment display. I will not consider the dot point in the data table and it will be off. We are going to connect these 7 pins of the 7-segment to a microcontroller's port, and we have to create this type of logic on the microcontroller's pins to get the required display on the 7-segment. Suppose we want to display 0 on the 7-segment common cathode display. The segment A to segment D will be high, segment E and F will be high, and segment G and dot point will be 0. The hex value of this data is 3F. If I equate the microcontroller port to this 3F data, then a 7-segment display should display a 0. Let's try it in the program. The display stands for 7-segment display connected to port 2. If I write display is equal to 0x 3f then semicolon, this 0x denotes the hexadecimal data, so it is important. Compile the program, the hex file to the microcontroller and mention the clock frequency and run the simulation. You can see I got a 0 on the 7-segment display because I write this instruction 3f, and according to this table 3f is required to display 0 on common cathode display. One important thing to note here is that I am not using any current limiting resistance for the 7-segment, but if we are going to deal with the hardware of 7-segment, then we must use the current limiting resistances on the port. Now if I want to display 5, then the hex value is 6D. I have to equate this display port equal to 6D. Compile it and run the simulation. Now I have this changed value on the 7-segment, which is 5. Now I will erase this instruction and create an infinite loop with the help of this while one. Now I will write the instructions inside this infinite loop to display the values from 0 to 9, and all the instructions will be repeated after few delay. Now I have these instructions under the infinite loop. First I am equating the display port equal to 3, which will display 0 on the 7-segment. Then a delay is there of 200 milliseconds. Then this 06 will display 1 on the 7-segment, and again there is a delay of 200 milliseconds. And in the same manner, I am just equating the port equal to the required value of the data. We can observe the output. Now it is started from 0, it will go to 9, and again it will come back to 0 because of the infinite loop. So I believe this is a very simple method to interface a common cathode display with the microcontroller. We have to just take care about the data which we want to display on the 7-segment. In next tutorial I will further discuss about the 7-segment displays. So thanks for watching and don't forget to subscribe the channel.